Matt Bauer, partner executive, iBase-t, and we're here today to talk about smart connected MRO. So the challenge that's faced by many MRO organizations today are essentially siloed, disparate information systems. Not at all unusual that many of the systems of record are simply integrated through PDFs, Excel spreadsheets, email messages, and unfortunately, when you've got this level of manual recreation of data, manual reentry, you get a lot of redundancies, and essentially it extends both the planning and execution phases of MRO. Inaccurate data leads to inefficiencies. This kind of situation can represent as much as 3 to 5% of MRO revenue today. We worked with PTC to envision a solution, a solution that utilizes both portfolios in order to create smart connected processes that allow us to overcome the manual inefficiencies that these organizations face. That solution is comprised of a combination of Windchill PLM, which is the product that manages, if you will, the superset of tasks, requirements, certifications, et cetera, that are required to maintain the product. It incorporates ThingWorx as a composite application, where we're using it to essentially mash up data from our Windchill PLM, along with data extracted from an FMS system or fleet management system that contains asset history and telemetry. Our execution engine is Solumina. Solumina is essentially, its job is to, if you will, present instructions, enforce work procedures, and capture audit trails and all associated data that goes along with the repair operation itself. We've augmented that with the addition of Vuforia for more complex repair operations that essentially can benefit, if you will, from visually guided work instructions. Now, all of that solution essentially, as I said, tags into the FMS system in order to access asset history, but it also integrates with the ERP system of an MRO provider in order to access billing, financial status, inventory status, et cetera. As I said, we envision a much smarter, more connected digital thread among all of these systems rather than recreating everything through emails, et cetera. What you see here in this simplified flow chart essentially is it's color-coded, so the green boxes are going to be PTC applications, the orange boxes are iBase-t applications, Solumina specifically. That middle box is essentially a ThingWorx composite app. And the reason you see it's multicolored is it's actually, again, it's mashing up the data from the Windchill under the LSA BOM along with our FMS asset history in order to create a tighter scope definition and assist the maintenance planner, reducing the scope of operations that they have to plan for. In our particular case, what we're going to be demonstrating today is a Lycoming IO360 engine, where Lycoming has essentially updated a particular aspect of the engine. They've updated the engine configuration. As a result of that, that configuration has to be updated in the Windchill, specifically in the LSA BOM. The LSA BOM is a Windchill add-on. LSA stands for Logistics Support Analysis. It's designed, again, to break down the barriers between design and engineering, and it contains the superset of all requirements for the product's maintenance. When this change occurred, in this case, we're going to be replacing magnetos on the engine, that kicks off a variety of activities that need to take place. The first activity will be the changing, adding those instructions for removal, addition, repair inside the Windchill itself. That will kick off what we call a service bulletin. The service bulletin is an indicator to all parties involved that these instructions need to be, the way the instructions need to be carried out. And in this case, because it's a safety issue, it's also going to be issuing an ICAT or an instruction for continued airworthiness directive, which is essentially grounding the airplane until that application is done. So what we see up top in terms of the flow is that generic process plan of getting those instructions into Windchill itself. kicking off the service bulletin activity that updates the generic task planning those instructions have to be communicated to the execution engine, and it's done so, as I said, in a generic way. Once all of that activity is completed, we turn to a very specific application of the service bulletin, which is for a particular tail number. And that's where our scope definition application in ThingWorx comes in by, again, combining the LSA BOM information with the FMS information asset history and giving us the specifics that are going to be needed to be done in this particular MRO operation. That is pushed to Solumina as a work order. Solumina then provides the instructions to the technician regarding the steps, the procedures, the tools, the certifications that are required. It will also activate, as part of that process, we'll also look and see how more complex repair operations are handled using Vuforia in order to increase the accuracy and reliability of those repairs. And then all of that as maintained information that's been updated in Solumina is made available back to the FMS or back into our composite application, so the as maintained data can flow back into any application that you so desire. What you see here in the blue connected lines are actual integrations. The red dotted lines in this case are integrations to outside systems. And you'll notice one purple line. The significance of the purple dotted line is actually that in addition to being able to de-scope the actual application or the actual repair operation, we can make recommendations back to the FMS in order to think of it, it's similar to an OEM that might give you a notice that your car, based on the mileage, needs the brakes changed. It's a similar concept, but essentially it gives the MRO provider the opportunity to be more proactive in terms of making recommendations regarding additional repair activities that might make sense during that particular event. So summarize this down even more from that simplified data flow into essentially a breadcrumb trail here. So the breadcrumb trail is going to tell us where we're at each stage of the procedure that I'm about to walk you through. So as I noted, this is starting with, this is all about the magneto replacement on a Lycoming IO360 engine. The fact that this is essentially more of a civilian asset, it really makes no difference from a procedure standpoint. The same processes, the same procedures are applicable in commercial aviation activities, in federal and defense aviation activities as well. So as I said, the first step here is now that the OEM has determined that this repair procedure needs to take place, we're going to walk through the update of the LSA BOM. What you see on the screen here is just the steps that you're about to see in the application when we run it. So everything in bold here is the steps you're going to see. There's a few that are not in bold that essentially we're basically, for the sake of time, we're not going to go through those, but you can assume that they have happened. So we're going to check the LBOM itself. We're going to work to include the design change. We'll analyze that LSA candidate in order to determine what we need to put into the LSA BOM. All of this activity around task analysis and generating the KPIs and creating the task requirements, we're going to assume that that's occurred, and then we'll create our maintenance task. You'll see that in the application. We'll create our task content. We'll assign any required tools and spares and subtasks to the LSA BOM. So we have a complete record of everything that needs to be done in order to complete this particular repair. Again, in the final stages, things like generating the technical publication or exporting the scope definition, we're not going to show that at this time, but those are all pieces of this particular process. So what you see right now is we're accessing the LBOM. We're hunting down the left magneto. We're going to update the left magneto. So in this case, we've selected that. We'll now go through and begin to update the actual procedures. So there we've got the magneto defined. We're now going to go in and essentially identify all of the candidates that need to be changed as part of this process. So going through, selecting the various tasks that need to occur. We'll then create each of those tasks within the application. In this case, for instance, entering the entering the information regarding the oil filter change, the magneto change itself, any additional operations that need to take place. We'll copy those. These are essentially the instructions for how to actually conduct the repair itself. So those are instantiated in the application. We'll identify the subtasks that are associated with all of these. So the complete record of what needs to be done is presented to the technician, creating the replacement task itself. Now we'll be assigning the spares and tools that are associated with the magneto repair. Essentially documenting each step, inputting the instructions, capturing or determining all the information that needs to be captured, adding the new tool, in this case a smart torque wrench, and there we go. And we've now confirmed that all of that input has been successful. We'll add another tool, essentially reusing some of that data the same way. There we go. And finalizing here in a minute. There we go. All right, so we're completed. So essentially what we've done now is we've updated the LSA bomb with all the required tools, all the required instructions, everything the technician needs essentially to know in order to conduct the repair. As a result of that, as I indicated, there's a service bulletin that's issued. The service bulletin is the detailed instructions issued by the OEM on how to conduct the repair. In this particular case, because it impacts the safety feature of the engine, the FAA gets involved, and an ICAD is issued. The ICAD is an instruction for continued airworthiness directive. Essentially what that means is the aircraft would be grounded until that repair was completed. So there's a sense of downtime and timeliness to the repair that needs to be complete. Once that service bulletin has been issued, Windchill issues a change notice to Solumina. Essentially, that change notice contains all the information necessary for Solumina to incorporate those task instructions, the generic task instructions on how to replace the magnetos, inside the execution engine itself. So as we can see, the instructions have been added to Solumina in terms of how to conduct the repair, and our process plans have been updated in order to reflect all of the required operations that need to be completed, as well as incorporating the service bulletin itself for access by the technician. So now that we've completed if you will, the generic update process, the generic update of the LSA bomb in Windchill, the generic update of task instructions in Solumina, now we want to zoom down and apply those instructions or those repairs to the specific assets that have been affected. In this case, what we know is that the LSA bomb is the master process list of everything that has to occur. In the fleet management system, we have a complete history, current cycles, flight cycles, flight hours, maintenance intervals, maintenance log records, a history of all life-limited parts and line replacement components, as well as any planned or scheduled MRO activities. So that service bulletin we're now actually able to zoom in on the particularly affected tail numbers that are affected by this particular service bulletin. So now we're going to step through this process of scope definition using the ThingWorx composite app. What you see here are just the steps that you're about to see in the application itself. We're going to refresh it first to display any of the upcoming fleet maintenance activities. We're going to see that there are 4 upcoming events. Obviously, a service bulletin takes our attention in this case, or takes priority in this case. We'll select the affected tail number that's been identified. You'll see the the macro information at the top of your screen. You also see a display of all the line replacement and the line limited items at the top of the page. We'll then drill down into each of the magnetos to show you the component maintenance history on each, so you can actually see what the maintenance history on these particular magnetos have been. We'll then refresh the task group for that tail number, and that'll display our next the set of tasks that are going to be required to be executed, and then we'll push that to our execution engine. Now this runs relatively quickly, so we're going to refresh the task groups. It comes up with our 4 events. We see the service bulletin. We're clicking on the affected tail number. We're then drilling down, essentially in each of these cases, we're drilling down into the particular item that we're looking for, which in this case is the magneto replacement. And we can see that the history on the left magneto, when it was last replaced. We can also pick up the history on the right magneto. And then once we've seen what that information is, this is the task that we want to complete, we use the MRO EXE button there to push that information down into Soluma for execution at the MRO facility. So all of those tasks have now been, if you will, the tasks that are going to be required. Could be some pre-tasks that are associated with the repair that makes sense to do at this particular point in time because of their condition or their flight hours, etc. All of those tasks have now been instantiated in Solumina, and Solumina then requests the work order from the ERP system in order to kick off the financial piece of the process as well, issuing a work order and preparing for the actual execution of the MRO event. We're now going to move directly to what the technician is going to see during the MRO execution process. We're going to start with the right magneto, and then we'll work through the left magneto. The right magneto is the simpler of the two, and will utilize Solumina's work instructions in order to guide the technician through the process. So you're going to see him sign in into the application. You're going to see that the service bulletin is available as a pop-up within the application. You can see the instructions for the removal and replacement of the right side magneto, the fact that we're going to collect a serial number. We're going to work through the steps of replacement. We're going to utilize a specific tool. In this case, the first tool that's selected, it requires a calibrated torque wrench. In this case, the first tool that's selected has not been calibrated. The application will alert the technician to that, require him to pick a separate calibrated torque wrench, which is then used. We'll collect the data from the serial number of the piece that went off, the serial numbers of the pieces that went in, and then we'll complete the buy-off process, and then we'll open the next step of the application, which will take us to the left magneto and introduce our before experience. So what we're seeing here is the operator has logged in. You can see the service bulletin is presented. It can pop up so that all the OEM instructions are available via the service bulletin, the official instructions, so to speak. We'll now view the instructions for disassembly. We're going to capture the serial number. That serial number can be captured either by typing it in or by a scanning process, depending upon how you decide to enter the data. We'll validate the tool calibration for the torque wrench. And as you can see, we just got an alert that torque wrench is not calibrated. So we're going to now select a second torque wrench that is calibrated instead. There we go. And we got green. So we'll now record the measurements, if you will, the key metrics from the torque wrench. Again, if it's a smart torque wrench, that could be collected automatically. It could be input by the technician at the point in time on the shop floor. We'll collect the installed part serial number that has been replaced on the unit, so we have a complete record of both removal and replacement of the parts, and we have traceability. And then we'll accept the buy-off right there. And now we've completed the replacement and all of the audited requirements of the right magneto. We're now going to move to the left magneto, and we're going to use a different approach here in terms of guiding the technician. In this case, The technician has a barcode to scan or a QR code to scan. You can use an iPad, pull it up, and then we're going to see what the technician is going to be looking at. All right, so the first thing is presented to us is a picture of the engine and the tools required. So this is what the technician would see looking through their phone or their iPad. Instructions are being provided in terms of the removal of the unit itself. So visually, you can see each step of the process. The technician can see each step of the process and visualize exactly what needs to be done. The gaps have come off, and now we're essentially going to put the new magneto back on. It's instructed us as to what tools to use for that magneto. We're now placing the magneto back on the engine, completing the process, putting the oil filter back in, and collecting the data. We notice that we've got the serial number of the serial number that was removed, the serial number that was put in, the installed date, all of the required audit information has been captured as part of the Vuforia process. And again, that information is fed back into Soluma. So we have a complete as-maintained record of the entire MRO operation. Once that as-maintained data is back, what we're going to do is update, and we can update the FMS directly, the fleet management system directly, and this information will go back into the ThingWorx composite app, updating all of the maintenance logs inside and essentially making that information available to any application that you would decide to store it in addition to the composite application itself. As you can see, we've got the right magneto that was the original, the one that was removed, and the new one that has been put on. And so we've now completed all of those tasks. We'll regenerate, and we see that it is complete. So all of our records have now been updated with all serial numbers. So what we've shown you here today is a more integrated, a smarter, more integrated end-to-end process from update and design and engineering all the way through execution and a return loop back. We're much closer. We're going to stay on track with our maintenance plans. We've, to a large degree, removed duplicate entry of information, etc. We're getting essentially faster execution. We're getting the right information to the right person at the right time in an actionable format in order to complete that. And the bottom line out of all of this is once you remove all those inaccuracies and manual effort that's involved in these types of activities, you can convert 3 to 5% of revenue conservatively. That's not 3 to 5% of EBITDA, that's 3 to 5% of revenue that can be dropped down into the bottom line of the MRO provider in order to increase profitability. And that really is the productivity impact that you can see with a continuous digital thread. Thank you.